All right, so we are in the week of October 19th through the 22nd. So we're covering blood and cardiovascular system. We already started blood last week, so we should be able to get through both chapters. So you've got a mastering A&P quiz over chapter 10 this week, as well as a Canvas quiz over chapter 9 this week. So next week we'll start lymphatic system, and then you also have exam 4 next week. Okay, this week you have quiz, all right? So just want to make sure you're clear on what we have to do this week and next week. All right, so let's go ahead and finish up our conversation on blood. I think we finished talking about red blood cells and white blood cells last class. So I think we were on platelets, okay? All right, so what are the platelets? So they are fragments, okay? And this is coming from the full notes for the chapter. All right, so these come from megakaryocytes. We learned a little bit about those last class. Got 150,000 to 300,000 per cubic millimeter in your blood. It only lasts about 10 days. So what's hemostasis? Yeah, basically. So hemo has to do with blood, stasis has to do with state, all right? And so in this case, you're stopping the bleeding, okay? So if you have a cut or something like that, you have to have a way to stop the bleeding, or you just bleed out forever, all right? So in people who have illnesses that prevent them from forming blood clots, that's what happens, okay? All right. So there's 3 stages or events. In the first stage, we call that vascular spasm. And in that phase, you get constriction or closing up or getting of some broken blood vessel. All right, so then we get second event, which is basically plugging up the blood vessel with a platelet. All right, so you get collagen fibers exposed in that broken blood vessel, and the platelets then are going to stick to collagen. And this aggregation or collection of platelets is what makes up our platelet plug. All right, third event is coagulation. So here you've got blood clotting, and you need lots of clotting factors for this to happen. So here there's 2 different ways you can activate the blood clotting. It can be intrinsic or extrinsic. Okay, so if the clotting factors are intrinsic or inside the blood, it is intrinsic, okay, involves exposed collagen. If the clotting factors are extrinsic to the blood, involving something like thromboplastin, it's considered extrinsic, or outside the blood. So this clotting process is said to be self-limiting, which just means it can stop on its own. And it is specific or confined to that area where the injury took place. Okay. So you wouldn't just want random clotting, right? You want it to be specific where you had a cut or a break in the blood vessel. All right. So looking at this in a little more detail, and actually before we do this, I want you to explain to your partner those 3 events, okay, of hemostasis. Why don't you explain those 3 events? You can do that at home as well. Okay, so if you're looking at the actual chemicals that are involved in the process, there's basically 4 stages. Okay, so, and that's specifically 4 stages at the coagulation process. So here you see in the picture, you have some damage to a tissue. You still have your vascular spasm, your platelet plug formation, and your coagulation, right? Under coagulation, there's 3 different steps involved. So first, you have to form an activator for prothrombin. Okay, so remember we talked about that for extrinsic coagulation or activation. Okay, and that activator is going to convert the prothrombin to thrombin. Okay, so then the thrombin is going to convert another chemical called fibrinogen to fibrin, or fibrinogen to fibrin. Okay, then those fibrin threads are going to wind around your platelet plug and start trapping your red blood cells, which makes your platelet, makes your blood clot. Okay, so just know you've got activating of different enzymes to make this process happen. Okay, so you got to activate prothrombin. You got to use that which you made the product to activate fibrinogen to make fibrin, and fibrin basically makes the fiber threads or fibrin threads that wind around and make the blood clot. Okay. All right, so we've talked about what happens normally. Let's talk about what happens when things go wrong. So, a few illnesses. One is thrombocytopenia. This happens when you have a low platelet count. Okay. Also, hemophilia, or hemophilias. This is a collection of inherited clotting disorders. And so this happens when you have deficiencies in those clotting factors we just talked about. Okay, so maybe there's a deficiency in prothrombin or thrombin or fibrinogen. Okay, so then you're not able to make the clots. All right. So if you get a stationary blood clot, it's called a thrombus. And if that blood clot moves and goes somewhere it's not supposed to, it gets dislodged, it's called an embolus. Thromboembolism happens when your discharged blood clot gets stuck and it just blocks the blood vessel, okay, which is not good. You're impeding blood flow. So pulmonary thromboembolism is if this happens in the pulmonary circulation. Those blood vessels are going toward the lungs, which is really bad because what does your bloodstream do when it gets to the lungs? It picks up what? What do you get from your lungs, anybody? Oxygen. Okay, so not only are you impeding blood flow, you're also reducing your ability to absorb oxygen. All right. Also, the cerebrovascular accident, which is a fancy term for a stroke. Okay, so a person can have a stroke if they have essentially a blockage in a blood vessel. Okay, and it could be caused by some clotting factor. Okay, it could be caused, could be a thromboembolism that's just gotten to the point that it becomes a stroke. All right, so let's talk a little bit about what happens at capillaries. Capillaries are small, tiny blood vessels, okay? So arteries feed into arterioles, which feed into capillaries. And they're areas where exchange happens because they're tiny and they allow for diffusion, right? And if y'all remember diffusion, Move substances from an area of high concentration to an area of low concentration, right? It's passive. So it does not require ATP. So lymph, we haven't really covered the lymphatic system yet, but lymph is another tissue fluid, okay? It has same composition as fluid in the tissues, okay? So it's a way for your body, if you've got too much fluid accumulating in your tissues, a way for them to get that fluid out. Okay, that's what your lymphatic system does. All right, also helps you with immunity, but also helps you monitor your fluid levels in your body. Okay, conditions related to that are edema. Okay, so because essentially at a capillary, fluid can diffuse out of the capillary into the tissue. Okay, and that over time it could build up and the levels of fluid can get too high. And that's what happens when you get edema. You get swelling in a specific location. And you accumulate fluid, tissue fluid. So how does this happen? It could have, the capillaries could become more permeable. Okay, so things can go out of the capillary more easily. Right, if you don't take up as much water as you need to at the venous end of your capillaries. So basically, capillary is in between an artery and a vein, right? So if you're not taking in enough water, taking enough water from the tissue, water is going to stay in the tissue. It's going to accumulate. Okay, if you increase the venous pressure, okay, pressure in that vein makes it harder for water to get in. Okay. Makes it harder for that water to leave the tissue. If your lymphatic capillaries also don't take up enough fluid, that can also lead to edema. And if your lymphatic vessels get blocked, okay, they're also not going to take up enough fluid. All right. So who here knows their blood type? And I'm not going to ask you what your blood types are, but okay, so about 20% of you know your blood type, right? So this relates to what we're getting ready to talk about. And if you don't know and you want to know, you give blood, they usually will tell you your blood type once you donated some blood. All right. So procedure here, blood transfusion, just means you're transferring blood from one person to another. All right. So why does blood typing matter for that? Well, you give someone blood and those two blood types are not compatible with one another, something happens called agglutination, okay? So we'll learn more about that here. So what are the different blood groups? So in order to know your blood type, you gotta know blood groups, okay? We determine these groups based on whether or not a person has inherited antigens, okay? So antigens are essentially proteins on your blood cells that serve as receptors, okay? And they look for things that could be bad in the body, okay? So basically what I want you to know is if the person has type A blood, their bloodstream makes what we call the type A antigen. And then they also have antibodies for B, anti-B antibodies. Okay, so they they're fine if they see the A antigen. So if you give them blood and that blood has an A antigen in it, their blood's okay with that. But if you give them blood with any B antigens, they have antibodies to attack it. Okay. Person has type B blood, they have the type B antigen on their cells. Okay, and they're going to make anti-A antibodies. Okay. So one way of thinking about it is whatever blood type they are, that's what antigen they have, they make the opposite antibody. Now, if a person has type AB blood, that means they have both antigens. Okay, so it means they're not going to make any antibodies. Okay, so they are good with either type of blood. Now, if the person's type O blood, they don't make any A or B antigens. Okay, so that means they're going to have antibodies toward both. All right. So here's your type A blood. So for type A, they have a type A antigen on these red blood cells on the surface. And they make anti-B antibodies. For type B, they've got the B antigens on their blood cells, and they make the A antibodies. You can see they have a little bit different structure here on the ends. Okay. AB blood, make both antigens, no antibodies. Type O blood, no antigens, both antibodies. Okay. So what we talked about, you got to make sure the blood typing is correct so you don't get agglutination. So agglutination happens if your antibodies inside your blood plasma combine with antigens on the surface of a red blood cell. Okay. So one thing I want to make clear on here, if you look, it has sort of a triangle shape here, right? This is round. And antibodies, this is round. Okay, so all right. So basically, as long as you have these types, it's okay. But if you have something that binds to it and it's round, it's going to trigger an allergic or immune reaction. Okay, if something can bind, it fits in here. All right, so you can see here, type A blood, type B antibody. Okay, they can't bind because it's the wrong shape. Okay, so you don't see any clumping. Agglutination is basically clumping. All right, now if you have type A blood of the donor and the recipient has those anti-A antibodies, your recipient's antibodies are going to attack the red blood cells of the donor. And you get clumping. You get what's called hemolysis, breaks down those red blood cells. Hemos, blood, lysis, it's to break down. So type O, if you have type O blood, you're said to be a universal donor. Why? Because you have no antigens. Okay? So you've got no antigens. So if you donate your blood to someone, regardless of what blood type they have, at least for the ABO group, they're not going to detect it as foreign. Okay, because you don't have any antigens on the surface of your red blood cells. If they have whatever antibodies they have, they're going to say, oh, this is fine. So if you're type AB, you're said to be a universal recipient. Why? Because you have both antigens. You have both antigens on your red blood cells. Okay. So regardless of what blood type you get, you already have antigens like that in your body. So your body's going to interpret that as normal. All right, for auto transfusion technology, it's one type of technology out there. They also have blood substitutes. Okay, so you can use these as an alternative to matching blood types. So if you have a blood substitute, you don't necessarily need to have someone donate blood. You have auto transfusion. Auto means self. So since you're able to sort of take a person, get blood sample from them, and then use it again later, okay, then that person would need blood from someone else. All right, so now that we learned about the ABO group, let's learn about the RH group. Okay, so the RH group, you have RH negative and RH positive. So if you're RH negative, you do not have antibodies to the RH factor, okay, until you're exposed to it. So it relates to illness in the sense of hemolytic disease of newborns. So it can occur in subsequent pregnancies, so after the first pregnancy, with an RH positive baby and an RH negative mother. So bilirubin, chemicals in the blood of your newborn, could actually end up causing brain damage or death. And you can prevent that by giving women that are RH negative, RH, essentially immunoglobulin or antibody injection. Okay. So here, child is RH positive, mother's RH negative. Okay, so if they're getting a RH positive from the father, all right? So red blood cells are gonna leak across the placenta into the mother. So the mother is now being exposed to the RH factor. She's now making antibodies that are anti-RH. Subsequent pregnancy, those antibodies in the mother are going to start attacking the newborn. Okay? And you have to give her medicine in order for that not to happen. All right. So how does aging affect your blood? Okay. Anybody heard of anemia? Okay. So anemia typically, again, has to do with someone who's having low blood oxygen or low iron. Okay, it could be an iron deficiency. All right, it's also another form called pernicious anemia. Leukemia is a blood disorder. Typically affects young people, but it can affect older people. All right, clotting factors, clotting disorders like thromboembolism. Okay, so typically as we get older, all the bad foods that we've eaten has that cumulative effect. Okay, you can get arteriosclerosis or kind of hardening of the arteries. As you get older, you can be more susceptible to thromboembolisms. But you can at least try to cut down on that by controlling your diet and exercise. Okay, so that's kind of concluding our section on blood. So while I start working on setting up our video for the heart, I'd like for you to talk to your partner about the different blood groups and how they work. And you can do this at home as well.